When we finally encounter an extraterrestrial life form, will we put it under a microscope or make friends with it? Either way, it's bound to change all our lives. ET Tech is the scientific search for extraterrestrial life. In Puerto Rico, the world's largest radio telescope is directed towards a distant star. It is monitored around the clock in the hope of detecting an artificially generated radio signal, evidence of an extraterrestrial civilization. At the Lick Observatory near San Jose in California, astronomers scan the heavens for a powerful light signal, beamed by extraterrestrial beings from a solar system trillions of miles from Earth. Meanwhile, 4 NASA space probes, launched in the 1970s, carrying information about our planet, continue their journey to worlds far beyond our solar system. These are some of the methods used by astronomers in the search for intelligent extraterrestrial life, the real ET. But how do we define intelligence?
If you can build a radio transmitter or a high-powered laser so that we can detect you, then from our point of view, you're intelligent.
While coming face-to-face with an alien being will be one of the crowning events in human history, scientists are no less eager to encounter those that can only be seen under a microscope.
Let's say if we go to Mars and we find evidence of microbial life, there are actually 2 things it could mean. One is that life on Mars and Earth are related. Somehow they're products of the same event, and as time went by, Mars can no longer sustain life. And so we may be looking at an ancient, distant cousin. The other possibility is it started of its own origin, not of Earth, but of Mars itself. Now that has the possibility of giving us a whole nother example of what life is like.
The attempt to discover life on Mars has been a scientific endeavor for over 100 years. In June 2003, the quest drew in a 9-year-old girl. She had won an American essay competition to name 2 robotic explorer probes destined for Mars.
She has in her heritage and upbringing the soul of 2 great spacefaring countries, to be sure.
Sophie Collis was from an orphanage in Siberia and adopted by an American family.
At night, I looked up at the sparkly sky. I felt better. I dreamed I could fly there. In America, I can make all my dreams come true. Thank you for the spirit and the opportunity.
Spirit and Opportunity are twin 400-pound solar-powered robotic explorers. After a 7-month journey, they landed safely in January 2004. They are the larger and more advanced descendants of the Sojourner rover that landed on Mars in 1997. NASA experts chose landing sites for Spirit and Opportunity where they think water may have once existed. Where there was water, there could be life.
There may be boundaries of grains could contain liquid water, and little microenvironments, microclimate areas could form. They could be niches. Martian life, if it exists, and we don't know, might actually have found pathways to go there and live in those tiny environments.
But before Spirit and Opportunity set off, they had to pass a cleanliness test carried out by a man with a unique job title, the Planetary Protection Officer.
I work to make sure that we don't contaminate other planets with biological materials from Earth, and that if we bring something back from another planet, we check it for life before we distribute it widely here on Earth.
John Rummel and his team were involved in the Mars mission right from the outset to make sure that the rovers were constructed in immaculate conditions. Some parts were sterilized prior to assembly. Then, as Spirit and Opportunity underwent their final preparations for the launch, the protection team continually collected culture samples from the rovers to ascertain that they were spotless.
You may look at a tabletop and not see the light that's there, but in fact it's very abundant. And a typical tabletop in an office is way too dirty to be sent to Mars.
While it was virtually impossible to remove every single microorganism, the acceptable limit for Spirit and Opportunity was deemed to be 300,000 aerobic spores.
That's about the same amount of microbial life as you would find in half a bottle of water that you'd buy in a machine or at the store. Very small bottle of water, in fact.
When Spirit was found to be well within those limits, it was placed inside the space capsule that would carry it to Mars. This was then taken to the launch pad, lifted more than 100 feet off the ground and secured inside the nose cone of a 3-stage Delta II rocket.
4, 3, 2, 1, engine start, and liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
And there's jettison, solid motor jettison.
This NASA animated film illustrates how Spirit and Opportunity, launched on the 7th of July 2003, intend to land and work on Mars. 37 minutes after launch, the capsule containing the rover separates from the rocket's third stage. It is attached to a cruise stage rocket, equipped with solar panels which provide enough power to reach Mars. 7 months later, the spacecraft approaches the red planet. 15 minutes before entering the Martian atmosphere, the cruise stage is jettisoned. The capsule, protected by a heat shield, enters the atmosphere at 12,000 miles per hour.
And here we are, we're coming straight in. Faster than a speeding bullet. We hit the Mars atmosphere, and we have 6 minutes to roll to a stop and then call home. 6 minutes, as many of us say, of terror.
5 miles above the surface, a parachute opens, slowing the descent. 20 seconds later, the heat shield drops off and the rover, encased in deflated airbags, spools out on a 66-foot-long bridle cord. 8 seconds before hitting the ground, the airbags suddenly inflate. Immediately afterwards, the capsule fires retro rockets, bringing it almost to a halt.
So we will cut the bridle. And now we drop to the surface of Mars, hitting the surface at something like 25 to 40 Gs, enough to black out a human being, but not our rovers.
The rover, nestled inside its balloons, begins to bounce across the surface, perhaps covering a whole mile before finally rolling to a stop. The airbags deflate and retract. Landing pedals open up in such a way that the rover will be turned upright regardless of its position on landing. Next, the power-generating solar panels unfold and a mast on which panoramic and navigational cameras are attached emerges. These give the controllers on Earth their eyes.
And if all goes well, we will receive the signals from those rovers and begin a type of expedition that will be previously unexperienced in our human condition.
The rover then rises up to its full height, unfolds its wheels from beneath it, and rolls off the landing pad. It uses infrared vision to help the men on Earth decide which rock or patch of ground is of greatest interest to them. Both Spirit and Opportunity are capable of traveling up to 44 yards in any direction each day. They're equipped with a whole battery of scientific instruments. Among other things, they can grind away the outer surface of a rock, take a microscopic view of what's inside, and then make a chemical analysis of it. It is inside the rock that clues about life might be found.
If some of the rocks are chock full of the stuff of life, molecules involving carbon and hydrogen, oxygen, nitrogen, above certain thresholds, these rovers could see those chemicals. And as I like to tell everyone, I've never met a rock that lied to me if you can read them right. So we have the tools to read the rocks.
Though it's possible that the rovers will discover life on Mars, it is far from certain. However, there is a strong possibility that the geological research will clarify where and how to look for life forms on future missions. While these robots represent a milestone in the modern search for extraterrestrial life, the roots of that quest are ancient. We can't know exactly when our ancestors first looked at the stars and wondered if they might glimpse a sign of something as alive as themselves. But in the late 1800s, an amateur astronomer excited public imagination with his theories about alien beings. We've been obsessed with Martians and UFOs ever since. Since the invention of the telescope in 1608, countless astronomers have gazed at the night sky, hoping to find evidence of life. In the late 1800s, it seemed that someone had actually found it. Percival Lowell was born into one of New England's wealthiest families. He read mathematics at Harvard and became a diplomat. His passion, however, was astronomy, and Mars in particular. In 1894, he used some of his personal fortune to build the Lowell Observatory in Flagstaff, Arizona, and he furnished it with the most advanced telescope of the time. The whole enterprise was dedicated to the study of Mars. Lowell published his findings in several books, and for the first time, the search for extraterrestrial life became a public obsession.
Lowell made maps of Mars, which were in many respects good maps. But he was one of those observers who tend to see lines connecting the features of Mars, and Lowell saw lots and lots of these. And he went on to speculate that these were canals.
His exploration of Mars suggested to him that there was a civilization there, that it was teetering on the brink of destruction, that Mars was a planet that was drying up, and that the people who lived there, or the entities that lived there, had created canals that would bring water from the poles to the various parts of the planet.
It was never so much science as it was a scientifically based flight of imagination.
Nevertheless, Lowell touched a nerve. Many people were growing more and more fascinated by Mars. On Halloween night, 1938, the interest descended into complete panic. Orson Welles' radio dramatization of H.G. Wells' novel War of the Worlds convinced thousands of terrified Americans that invaders from Mars were attacking Grover's Mill in New Jersey.
I'm extremely surprised to learn that a story which has become familiar to children through the medium of comic strips and many succeeding novels and adventure stories should have had such an immediate and profound effect upon radio listeners.
Following the broadcast, and then again immediately after the end of the Second World War, Americans reported so many sightings of UFOs that in 1947 the Air Force initiated Project Blue Book to investigate and document the incidents.
In the immediate post-World War II period, adults and children alike were in possession of these airplane cards which had silhouettes, and you would look up in the sky and spot whether an airplane was friend or foe. And I suspect that had something to do with the UFO craze, because once people start looking up expecting to see flying objects, and then if they see a light or something that they can't identify, it becomes an unidentified moving something.
Walter Cronkite examined the UFO phenomenon in a documentary broadcast in America in 1966.
From the beginning of recorded time, men have been seeing unexplainable things in the sky. And there's no reason to doubt they saw something. The question is, was what they saw really there? And what was it they really saw?
Cronkite and other reporters interviewed supposed eyewitnesses, some of whom even claimed to have been on board a flying saucer.
And they had a compartment in the wall which both cleans and deodorizes their clothes by some light process, which required no water, soap, or detergents, or a washing machine.
Among the interviewees was a young astronomer from Cornell University, Carl Sagan, who would go on to become an important figure in the search for E.T. He believed the UFO phenomenon was rooted more in religion than science.
It's a way of having beings that come from the sky, that are worried about us, that are powerful, that are going to step in and prevent us from destroying ourselves, as we may very well might, and yet have it in the cloak of science.
Amid accusations by witnesses of UFO incidents of a government cover-up and conspiracy, the Air Force terminated Project Blue Book in December 1969. It had investigated a total of 12,618 sightings. 701 remained unidentified.
When it comes to extraterrestrial life, I really don't believe that there's a cover-up here. To begin with, I'm not quite sure why the government would want to keep that secret. But, hey, even if you want to believe that they would keep it secret, do you think that every government wants to keep it secret? Are the Bulgarians keeping it secret, right? Are the Czechs keeping it secret? Are the British keeping it secret? Right? Or do the aliens only land in America, so only one government has to be worried about this?
In 1960, at the height of the UFO frenzy, and when the space program was still in its infancy, a radio astronomer called Frank Drake introduced the first legitimate scientific method for researching extraterrestrial intelligence. Radio astronomy emerged as a science in the late 1930s. It was discovered that celestial objects like galaxies, their stars and their planets emit naturally occurring radio waves that can be detected on Earth by radio telescopes. Always sited in remote areas to minimize interference, the telescope's dish collects the waves and bounces them to a reflector. The reflector focuses the waves and feeds them to a receiver located at the bottom of the dish. The receiver amplifies, then transmits the signals to computers. They are analyzed and made into visual representations or maps of the source from which they originated. From Earth, man-made waves generated by radio and television broadcasts have been traveling through the universe for about 100 years. They could conceivably be detected by extraterrestrial civilizations that have some form of radio technology. And conversely, we could detect their transmissions.
I think it's likely that all civilizations pass through an era as we are now passing through, in which we have very high-power television broadcasts which can be detected by other civilizations. There will be such a period. Other civilizations will have their I Love Lucy, and we can capture it, and it doesn't take much to do it.
In 1960, Frank Drake was a radio astronomer at the recently opened National Radio Astronomy Observatory in Greenbank, West Virginia. That year, Drake pointed the observatory's radio telescope towards certain specific stars in the hope of detecting radio waves that had an artificial signature.
When we were observing, we didn't listen because the signal that comes out of a radio telescope is just static and noise unless there's really a signal there. But we had a pen and ink recorder. Then you watched the squiggly line and you hoped that at some point the pen drawing the squiggly line would jump over to one side, which is what you would get if there was actually a signal being detected.
Drake named his experiment Project Ozma, after the fictional Princess of Oz.
The land of Oz was a land far away, very difficult to reach, and populated by strange and exotic beings. And so that's a good description of the place we're trying to find.
Project Ozma never detected an intelligent signal. But Drake had laid the foundations for what would become SETI, the Search for Extraterrestrial Intelligence. SETI would come to be the acronym applied to all radio telescope searches for artificially generated radio waves. But in 1960, the general public wasn't enthusiastic about radio waves. People preferred the idea of blasting into space in a rocket and meeting ET face to face. The race to get to the moon dominated the American space program in the 1960s. But even in its earliest days, NASA also pursued planetary exploration and the search for life using unmanned probes. The first series of these probes, named Mariner, visited our closest neighbors, starting with Venus.
Venus is covered with clouds, so for many decades observers could tell almost nothing about it. In that absence of evidence, a lot of speculation flooded in about how, well, if it's cloudy, Venus must be like a rainforest, and under there would be these wonderful tropical forests and abundant life forms and so forth.
Mariner 1 was launched on the 22nd of July 1962. Its task was to survey Venusian atmospheric and surface conditions.
20 seconds and going up very nicely.
5 minutes after the launch, the rocket carrying it into space veered drastically off course, so ground controllers blew it up, thus destroying Mariner 1.
Blew up. It's a big ball in the sky.
Mariner 2 was successfully launched 5 weeks later. After a 4-month journey, it became the first spacecraft to encounter another planet when it began its orbit of Venus. As it was not equipped with cameras, these images were compiled from a later probe, but Mariner 2's sensors indicated that Venus was an inhospitable place. It suffered from what is called a runaway greenhouse effect, with a thick atmosphere of carbon dioxide and surface temperatures of 900 degrees Fahrenheit. The search for extraterrestrial life then moved to our next closest planetary neighbor, Mars. On the 15th of July 1965, Mariner 4 flew to within 6,100 miles of the Martian surface.
What it showed us was surprising. It saw a Mars landscape that reminded us more of the moon. All of this astronomy, careful thinking, the best measurements we could make from Earth, had shown us a Mars that was dynamic, exciting, possibly life-bearing. And then we saw the lunar face. Not a place you'd expect to find life.
Not everyone was disillusioned. Mariner 4 sent back a total of 21 grainy black and white photos, which only covered less than 1% of the planet's surface. A more advanced probe was launched in 1971. Mariner 9 eventually photographed most of the surface of Mars. Unfortunately, it arrived in the middle of a massive dust storm.
We actually had to wait 3 months before we ever took a photograph of the surface. Mariner 9 happily waited as the dust storm subsided, and the first land it saw was the peak of a 90,000-foot volcano.
The gigantic volcano, named Olympus Mons, showed here as photographed by Mariner 9, and here by a more advanced probe some years later, is the largest known volcano in our solar system. Having sent over 7,000 photographs back to Earth, Mariner 9 provided a comprehensive view of the planet's surface. It possessed much higher resolution cameras than all previous probes. In addition to volcanoes, Mariner 9 also revealed the Val Marinaris, a 3.5-mile deep, 3,000-mile long canyon, and also numerous dry riverbeds. The combination of heat generated by volcanic eruption and flowing water would have provided the perfect environment for life sometime in the past. The questions of whether it was still in existence, and if so, how to find it, or at least evidence of its extinction, were then the hot topics of science. Enter Project Viking.
Viking is the big enchilada when it comes to a Mars mission. This was a major effort. It included 2 landers and 2 orbiters, multi-billion-dollar program.
The Viking landers were little robotic laboratories designed to conduct tests relating to the Martian surface.
They could look for evidence of internal activity through seismographs, conduct 5 life-oriented experiments looking for the chemistry of life and how life might metabolize in a Martian system, how it might produce chemicals.
Viking 1 touched down on the 20th of July 1976. Viking 2 arrived 4 months later. The immense thrill of actually landing 2 sophisticated mini-labs on another planet soon gave way to sobering reality. Both landers scooped up and analyzed Martian soil. But the tested samples showed not even a trace of carbon, the major element in the chemistry of life. In fact, it was considered that the surface of Mars may be sterile because of the intense levels of radiation the planet receives from the sun and from deep space. The Viking landers, which are still there on Mars, failed to accomplish one supremely important goal.
We never actually touched and analyzed a rock. The little chips of things we thought were rocks in the soil we grabbed ended up being dirt clods. So we did not analyze, with this incredible gear, rocks. Well, as I tell kids when I get a chance, rocks are Mother Nature's artifacts. They tell us the story about how planets are made, environments, what environments the rocks were formed in. So we got to get to the rocks.
But in August 1996, 20 years on, it appeared that at least one rock had come to us. NASA officials announced that a Martian meteorite found in Antarctica contained possible evidence of life in ancient times. It was thought that the 4-pound rock was formed about 4.5 billion years ago, when Mars was warmer and probably possessed large amounts of water. Then, about 15 million years ago, a large asteroid struck Mars and jettisoned the rock into space, where it remained until it landed in Antarctica about 13,000 years ago.
A team of scientists doing analysis at a microscopic level, really an electron microscopic level, found what they think are the remnants of some sort of microbial bacteria that looks fossilized. The result of that was a furor that existed in the scientific community for some time, and a debate that still is taking place in the scientific community over whether or not they're right.
The largest of the specimens were less than 1/100th of the diameter of a human hair. They appeared somewhat similar to microscopic fossils of the tiniest bacteria found on Earth. Plans for the first flights to Mars since Viking had already been drafted, and were being scrutinized when the discovery of the Martian meteorite was made public. The project was vitalized by the renewed possibility of finding extraterrestrial life. One of the most ambitious missions was Pathfinder. Like Viking, it would carry a lander. Unlike Viking, which was stationary, Pathfinder would include a 6-wheeled roving vehicle called Sojourner.
So, by being mobile, we can go and touch the rocks. We didn't get to them on Viking, even though they were all around us. And that is part of NASA's newly crystallized Mars strategy.
Launched on the 4th of November 1996, Pathfinder landed on Mars on the 4th of July 1997. The next day, to the joy of its jet propulsion laboratory handlers, Sojourner rolled off the Pathfinder lander and began to roam over the Martian surface. Like all the missions before it, Pathfinder found no signs of life, but its true achievement was to prove the viability of the technologies necessary for more advanced missions, like those of Spirit and Opportunity.
We have ignition and liftoff of Atlantis and the Galileo spacecraft bound for Jupiter.
A good deal of the work on possible extraterrestrial life in our solar system has focused on Mars. But NASA has also launched a small armada of probes to seek evidence of life elsewhere. One of the most significant was Galileo. Launched in 1989 from the payload bay of the space shuttle Atlantis, its task was to study Jupiter and its moons. Controlled by a computer less powerful than a Palm Pilot, Galileo experienced a number of technical difficulties on its 6-year voyage to Jupiter. But after it began to orbit the gas giant, a planet 318 times the size of Earth, it sent back brilliant pictures. Even more exciting is what it found when it orbited one of Jupiter's moons, Europa. Galileo sent back photographic evidence that salty oceans exist beneath its icy surface. Scientists now think primitive life may very well be discovered there, based on where we first found it on Earth.
For instance, Lake Vostok is a subglacial lake in Antarctica. This lake is under 3.7 kilometers of ice. It's been isolated from the outside world for maybe 30 million years. And from samples of ice, we find microbes that are from the lake. So this isolated environment has life in it.
Based on Galileo's findings, plans are already underway to develop JIMO, or the Jupiter Icy Moon Orbiter, which will hopefully gain a deeper understanding of Europa's underground ocean. Galileo also held out the possibility that life might exist on another of Jupiter's moons, Io. Rather than having a salty ocean, Galileo showed Io to be a place of active volcanoes, another environment where life, theoretically, could exist. It was the possibility of life on Jupiter that led to Galileo's destruction. In September 2003, it was transmitting the last of some 14,000 images back to Earth. It had outlived its original specifications by 6 years, but it was running out of the propellant used to keep the antenna pointing towards Earth. This antenna enabled engineers to control its course. Once that control was lost, NASA feared that Galileo might collide with Europa and that it might be carrying microorganisms from Earth.
If you look at the ethical reasons for keeping microbes off of other planets, you essentially don't want to despoil other bodies that may have their own life and have Earth life come into conjunction with that other life. It's very important that if we go out to learn about a place, that we not find the contamination that we brought ourselves.
Therefore, the controllers transmitted instructions to Galileo to change course, to go back towards Jupiter, and then take a 108,000-mile suicide lunge into the planet's dense atmosphere. It was crushed and vaporized by heat and friction before ever reaching the surface. While NASA searched for signs of simple life forms within our own solar system, in 1992 the agency also initiated a plan to search for intelligent life far beyond it. Almost all of NASA's probes have researched planets within our own solar system for signs of life most likely to be tiny microbes of some kind. But 4 probes launched in the 1970s, all carrying messages for extraterrestrial beings, continue to penetrate into deep space. Pioneer 10 and Pioneer 11 surveyed several planets before being directed to places where, conceivably, they could encounter an intelligent alien. With that in mind, NASA attached a gold-plated plaque to each probe as a kind of greetings card. It was designed by Carl Sagan, his wife Linda, and Frank Drake.
We decided we would draw a map showing the location of the Earth with respect to some identifiable objects, pulsars in fact, and give sketches of human beings.
Pioneer 10 sent its final radio signal back to Earth on the 23rd of January 2003. It was then 7.6 billion miles away and still continuing its journey into deep space. 2 additional probes that will also leave our solar system, Voyager 1 and Voyager 2, were launched in 1977. For these, NASA created gold-plated records containing images and sounds of planet Earth.
Hello from the children of planet Earth.
We wanted to show the good side of us. So there's no war picture, there's no nuclear bomb picture, there's no dentist drilling picture. So in a way, the record doesn't give quite a balanced picture of our civilization.
NASA's probes were the luminous successes in the search for extraterrestrial primitive life during the second half of the 20th century. But SETI radio telescope searches for extraterrestrial intelligence have been quietly expanding since Frank Drake inaugurated Project Ozma in 1960.
Our spacecraft that go to the planets look for primitive life. With the radio search, we're looking for advanced life, and it's surely not in our solar system.
But it could be in our galaxy. Shortly after initiating Project Ozma, Frank Drake devised a formula that is still used to calculate the potential number of detectable intelligent civilizations in our galaxy, the Milky Way.
I sat down and wrote down all the things you need to know about to predict the number of detectable civilizations in the galaxy. I wrote them all down and I realized, well, if you multiply them all together, you get the number of detectable civilizations.
The Drake equation goes like this. Take the number of stars in the Milky Way, times the fraction of stars with planetary systems, times the number of planets per solar system that are suitable for life, times the fraction of suitable planets on which life might actually appear, times the fraction of life-bearing planets on which intelligent life emerges, times the fraction of civilizations that develop a detectable technology, times the length of time such civilizations release detectable signals into space. There is no correct answer. The equation is devised to permit astronomers to insert their own numbers and to draw their own conclusions.
If you put in my numbers, they predict that about once per year in our galaxy, a new technical civilization arises. And that may sound like an awful lot, but this is 1 out of 200 billion stars. Each year produces a new civilization. So it's not all that wild. At the same time, it's very exciting. It means there have been lots and lots of them produced, and literally billions in the history of the galaxy.
As more conservative astronomers than Drake calculated his equation, the idea that huge numbers of detectable civilizations must exist in our galaxy has gained ground. Several university and private observatories began to conduct their own SETI experiments. In 1984, the SETI Institute was formed to advance and coordinate research. 8 years later, on the 500th anniversary of Columbus's discovery of the New World, NASA started its own SETI project in cooperation with the SETI Institute. It utilized NASA's Deep Space Network telescopes, normally used to track satellites, and the enormous Arecibo radio telescope. Secluded in a valley in the jungles of Puerto Rico, Arecibo is the world's largest and most sensitive radio telescope. The dish is 1,000 feet in diameter, and the reflector weighs 900 tons.
We started down what we thought was going to be a 10-year-long path to survey 1,000 nearby stars and to survey the whole sky.
The amendment I am offering today will eliminate funding for what I believe to be a foolish and wasteful NASA program.
Only a year later, in 1993, the US Congress shocked the SETI community by cancelling the program's annual budget of $10 million.
The problem that existed was members of Congress very much questioned what they referred to as the search for little green men. And specifically, some members of Congress made this a crusade.
Rather than accept defeat, the Institute started a fundraising campaign led by Barney Oliver. Oliver was an executive at Hewlett-Packard, who, among many other things, is credited with the development of the handheld scientific calculator. While on leave of absence from the company, he led NASA's short-lived SETI project.
Barney just decided that this was something he was going to take on, and he took on a new career as a fundraiser.
Barney Oliver's efforts resulted in Project Phoenix.
Phoenix rising from the ashes of congressional termination.
Today, Project Phoenix is examining 1,000 nearby sun-like stars using, among others, the Arecibo telescope. For several weeks of the year, SETI Institute scientists stay at Arecibo, working round-the-clock shifts to conduct the research.
The popular image of what it's like to go to the telescope and listen for ET is probably best illustrated by what many people saw in the movie Contact, where Jodie Foster sits on the hood of her car with a pair of earphones, kind of dozes off for 30 seconds, and then hears something that sounds like a major accident in the Philadelphia Symphony Orchestra's timpani section or something like that. That's not the way it is. We don't know quite where on the radio dial the signal might be coming in, so we monitor tens of millions of channels. So you can't wear tens of millions of earphones. That's terribly uncomfortable, not very effective. We sit there in front of a bank of computer screens, and the computers are doing the listening. If the computers decide that this signal looks pretty good, they'll beep at us, they'll get our attention. We will get involved at some point in the loop. But mostly, it's the machinery that's listening for ET.
Virtually all SETI Institute searches for extraterrestrial intelligence have relied on hiring time on radio telescopes that are constantly in use on other astronomical assignments. Over the next few years, the Institute will begin to conduct research using their own telescopes 24 hours a day, 7 days a week. The range of research will also increase dramatically. This is the result of a $12.5 million grant made by the co-founder of Microsoft, Paul Allen. The money will be used to construct the Allen Telescope Array in Northern California. The Allen Array will consist of 350 small, inexpensive dishes linked together to form a sort of extended radio telescope. The array doesn't offer the sensitivity of the giant Arecibo, but it has other advantages.
Arecibo has the biggest collecting area. It can find a particular signal at a greater distance, but it can only look at one direction at a time. And so in the beam that Arecibo makes on the sky with its large single dish, I'm only going to have one star. But with the Allen telescope array, now I've sacrificed collecting area. And what I've gained is this ability to look at multiple directions at the same time and look at multiple stars and speed up my search.
So that means now that we're putting an outboard motor on the Nina Pinta in Santa Maria, the chances of discovery begin to go up. And then after that, we keep putting on more motors because technology, mostly computer technology, allows this basic array of antennae to get faster and faster in their scrutiny of the heavens.
While SETI has always been associated with radio telescopes, the Institute has recently brought in conventional ones for a project called Optical SETI. At the Lick Observatory near San Jose in California, scientists are looking for beacons of light, perhaps high-powered lasers being flashed towards Earth as a message from another civilization.
Can we say why they would want to do that? Well, of course, that's alien sociology. We don't know a whole lot about alien sociology, so it's a little hard to kind of second-guess why they might do that. But it would be very easy, perhaps easy to the point of being a high school science fair project for them, to mount a campaign of pinging the nearest 10,000 or 100,000 stars with lasers, hoping that somebody will see their signal.
To identify such signals, a sophisticated light pulse detector box is attached to the back of a telescope.
And what happens is the telescope is just aimed at nearby stars, and that box is looking for quick flashes of light, not the steady starlight that any telescope can see, but very short pulses of light, a billionth of a second or less, really quick flashes, because those are things that stars don't make.
If the computers associated with either an optical SETI or a radio SETI detected a signal, the scientists monitoring them would immediately conduct a series of tests to make sure the computer readings were accurate. Then they would ask observatories around the world to examine the signals to confirm the findings.
The first thing that we're going to do, if and when we get the confirmation that we found a signal, is we're going to open the bottle of champagne that's sitting in the refrigerator at Arecibo and do a little bit of celebrating.
Whether newly discovered cosmic relatives will crack open a bottle with us is still a bit of a mystery. But the quest to find extraterrestrial life will probably continue for as long as human beings ponder whether or not we're alone in the universe. The search might outlive humanity itself, in the form of the gold records on the Voyager probes, which may travel through space for eons to come.
About 5 billion years from now, the sun will expand, swallow up the Earth. Everything we know will be vaporized. But a record of our existence will exist for anybody who wants to learn about us. And that once upon a time, far away in the galaxy, there was a place called Earth and a civilization run by human beings.
And perhaps something else will be realized about human beings. That one of their greatest desires was to peer into space and realize they were not alone.